Alright, so this is a concept that just goes back to what you guys learned in quarter one. Remember, I equals the square root of negative 1. So what I'm going to do is I'm going to break 11 into negative 1 times 11, and I'm going to square root each term individually. The square root of negative 1 is I, and the square root of 11 I can't do anything with, so this problem is done. So let's say that you had something a little different. Let's say it's negative 24. Okay, square root of this. Well, I know that 24 is negative 1 times 24. But I know 24 has a perfect square that will evenly divide it. Now, what are my perfect squares? Perfect squares are 4, 9, 16, 25, 49, 36, right? It's just any number, 6 times 6, 2 times 2, 3 times 3, 4 times 4, right? And so 24 I know is 4 times 6. Okay, so now that I've basically created prime factorization out of this, I can go the square root, and square root. The square root of negative 1 is I, the square root of 4 is 2, the square root of 6 stays the square root of 6, and so I just got to make this look pretty, so I go 2I square root of 6. And that problem is done. Let's do one more. Let's do the square root of negative 54. Okay, well 54 I know is divisible by 9, so it's going to be 9 times 6 is 54 times negative 1, square root, square root, square root. I, 3, square root of 6, 3I, square root of 6. Okay? And that's it. That's all you do. And you continuously are using your perfect squares to figure out which one evenly divides a number underneath a square root. So 4, 9, then 4 times 4 is 16, 5 times 5 is 25, 6 times 6 is 36, 7 times 7 is 49, and the list goes on.